anywhere in the world. As I've mentioned, that we offer programs that allows you to sort of like connect with engineers from different parts of the globe. And then on that note, I will then leave things to Abdu.
Okay, thank you, Barry. So hello, everyone. Let me first look at how can I take control. Yeah, I think I can take control from here. Great. So hello, everyone. Welcome to this webinar. Thank you for taking the time out of your busy days to attend this session. It is much appreciated. So to introduce myself, I'm Abdu Shaalan. I am the program leader for industrial automation at ACT for undergraduate and postgraduate programs. For me, I take care of the entire program from the point of making sure that it is from a high quality program, and teaching materials and the supporting staff are all doing their best in order to support the students. And as well, I deliver a few modules. My background is mechatronics. I had my master's in engineering management and then PhD in industrial automation and maintenance practices. I did taught and carried out many different teaching and research initiatives and opportunities with the ACT and previously with my previous institution, University of Sunderland. So for today, it is all about getting you familiar with what is industrial automation, how does it work, and why would I be an industrial automation engineer or whatsoever. So we will cover a few things today. We will start with an introduction to industrial revolutions. We need to know where things came from and what is industrial automation, how PLCs or the brain of an automated system works. We will look at the pneumatic system in a very brief way, and we will look quickly into how can we at ACT deliver this and what is the potential employment and career opportunities that you might have. So before we start, I would like actually to ask you if you can tell me which background do you have or what do you do at the minute. It will be useful really to get to know you more. So we have Goodwin here is an automation engineer. Christian, program development management. Interesting. So what got you interested in industrial automation, if I may ask, for King? Instrument engineer, electrician, electrical and electronics engineer. So are you guys interested in bachelor or the master's, or what degrees do you have at the minute? You are looking for PhD studies?
Sorry, Abdu, I just want to check if you managed to take control on your side.
Yes, I have control.
Okay,
that's
perfect.
Fine.
Thanks.
Bachelor's in electrical, biomedical. Great. So that's very interesting. Quite a good mix, interesting mix. For IOMIDE, we don't offer PhD studies at the minute. We will soon, but that's not something that we can start taking applications for, unfortunately. Navigation officer on board. Okay. All right, let me have a look. Yes. Okay, no problem. Okay, well, that's a good mix. So for today, some of you might know a lot about what we're going to say today, or actually all of it. So it is all about getting you more familiar if you don't know what is industrial automation, what does it do, what can you do with it. This is going to be useful for you, but for the people that works in automation systems and they know really what's industrial automation, that might not really be of the highest beneficial to you, but you're definitely welcome to stay and see how can we explain things. This might be if your interest, if you are pursuing one of our master's degree, for example, as we offer master's degree in industrial automation as well. But for today, it is kind of a basic introduction. So to start with, as I just mentioned in the agenda, we need to know where things came from. And to know where things came from, we have to first know what are the different industrial revolutions that we lived through so far. So all of us heard about Industry 4 and the bang that came with Industry 4, and now we are living in Industry 5, and there are talks about Industry 6, and things are moving rapidly, really. But let's start to focus on the first four and stop at that fourth one. So when we say the fourth industrial revolution or Industry 4, well, this means that there were three before that. So when we start to look at them, we have the first industrial revolution, and that happened during the 17th century, 18th century kind of thing. And the whole idea of it was, how can we start to use an external power source other than ours? So all the history says that everything has been made by the use of the man force and that person is driving certain tools to do different things. So the main power source was that man or that person. And that was always the case until that 17th century point. So this is when we started to use external power source, and we started with the steam engines. And that was a revolutionary finding. Now we started to have much more power that can drive much bigger tools, and we can start to shape much complicated tasks. And things developed and things became widely used everywhere, like how we can use here, how we can see here with the steam train, or as we can see it with all the different steam engines that they were in factories. So that was a big thing. And because of this, we started to have connections between continents and countries in a much bigger way, or a much better way. So the impact on logistics was very massive. And that was the whole engine behind the second revolution. So the first revolution, when you start to think about it and how things were getting made. So it was a person, and you might live in a small city or a village, and you only have one carpenter that makes tables, for example. So that person only serves his own village or city, and things were customized. So you go to that carpenter, I want a table with that shape, that height, this color, whatever it is, and that person will do it or make it for you. But when we started to have that external power source and the logistics improvement, like how we started to have trains and reachability to different places, the demand for our products became bigger, and we started to have reachability, so we can go to these places. And that was the whole idea of the second revolution. We started to have production lines, because now we need to start to make things to a scale, to high scale, because I can start to reach the next village and the village after and the country after and the continent after. So my market, or my base market, grow dramatically. And this was the second revolution. We started to have production lines. We eliminated customization, and we started to have fully one type, one model, like how we can see here. This is the first production line that was made by Ford in the US, and it was making that Ford Model T car. So exactly the same car, same color, there is nothing different, and that's it. Make a lot of it as quick as possible and sell it. But with everything comes the problem of it. So an issue with it was, how can we control this production line? It is quite complicated. You have many different steps and many things have to work together. We didn't have computers. We didn't have anything. So it was all based on a control room, or usually called relay room. So think about it as a big room full of switches and electric circuits. to connect and control all of these different devices together. So quite complicated. And if anything went wrong, it's not easy to fix. And if you wanted to upgrade or update the system, it's not as easy as well. So that was a big issue. And all of this kept going until the third revolutions or the 60s. And this was when the first computer was made. We started to have the first intelligent system that can take orders and execute certain tasks based on these orders or this program or code that you are going to include to it. So that was a massive improvement, and this is what we live at the minute. And the whole idea of the industrial automation or that automation systems and the introduction of computers was how can we replace this big room with very much smaller device that can do all these jobs. So that was a big change. So what is that computer, or what is this controller came from, or what does it do? So it's a device, it's a versatile, programmable digital processing system. And the whole idea of it, think of it as your brain. And your brain takes information, you have lots of inputs, and the inputs to your systems are your eyes. You can see what is there, the presence of objects, you can hear, you can smell, you can sense. All of these are inputs to your brain, which is the processing unit. And then you start to react and have an output that can apply forces to the surrounding environment, using your arms and using your legs to reach to things and to walk and to do different things. So the same thing is within these microcontrollers. It is a processing unit that you can connect inputs and outputs to it, and based on a program that you write and include to it, we will not get into that full structure of how a microcontroller work and how the different registers and the structure of it work, but rather than we're going to just talk from a higher level from the fact that it is an intelligent device or a processing unit that can hold information and logics that you write yourself. So you started to see in the 60s and the 70s the first computers, and it was revolutionary applications. And based on this came up the first PLC. So the whole idea of that microcontroller, how can we put it in, or how can we use it in a harsh environment? A factory, it's not a friendly environment. It's hot, it's wet, it has humid, it has dust, it has debris, it has many different things. So the whole idea of a PLC, and the PLC is the device, that controller that controls machines in factories, is that it is inside this box. This is the first PLC that was made, not much different from what we get now, rather than just more elegant, let's say, in how it looks, and different. Of course, different capabilities and applications, but looking wise, it is something similar. And the whole idea that it is a microcontroller like this, put inside a box to protect it, and different circuitry to make it able to work in such environments and to drive higher loads or bigger machineries. So following this, we started to have Industry 4. We all know about Industry 4, and it is just a collective of different technologies. And all of these technologies came around to tackle certain issues we were having in the industry. Not sure why it is not showing what's inside the slide in here. All right. So collection of technologies, and this collection is many different things. So one of them is connectivity, and this is one of the most important ones between different devices. So if you're from the background of industrial automation, so you would know about industrial automation, so you would know how difficult it is in the past to connect different brands of PLCs, for example, together, or to connect different systems together, because it was all wired in general, and there were no internet connectivity capabilities within the PLCs. You have AI, you have robotics, you have cloud computing, cybersecurity. All of these are different pillars of Industry 4 that can help to do different things within our systems. But we will not really have much of a focus on them today. So that was the whole idea, and that was where all the different industrial revolutions, what do they mean, and what impact did they come with? So when we talk about industrial automation. So as we just said, you have a processing unit, or that the processing unit, the brain, like how we said with yourself as a human. And what you have inputs and outputs. And looking at the input side, you can have sensors, like how you have your eyes. Let's say it's a camera. So you have different sensors that can give you different surrounding environment criteria. So you might have a temperature sensor, a vibration sensor. You might have a proximity sensor that detects the presence of different objects. You can have all different types of sensors. So all of these different sensors can work as an inputs. So they give you information about the surrounding environment. The temperature is X. The vibration parameters are whatever millimeters, 20 millimeters per second. The elevation, the stress, the weight, all of these different things. And based on your logic and the program of instruction that you write, you start to use these inputs to drive different outputs. And the outputs can be all the different motors, conveyors, cylinders, whatever it is that depends or to work as your system. So to give you an idea of what an automated system works, or what is or how does it work, that automated system, I give you the example of the thermoforming process. If you're not familiar with thermoforming process, this is the process that you will find any food box that you might buy from online or from the shops, these flimsy, clear boxes for food and for maybe medications, all the different enclosures of medicines, different things. So it is usually used in the food industry and the medical industry to make all the packaging for them. So I want to show you this first. So to understand first, how can an automated system work?
Inline thermoforming is a high production process.
Can everyone hear the video?
Yes.
Okay.
Goes to a heating station, also called the heating tunnel, where multiple banks of heaters heat the plastic in stages. The sheet moves or indexes to the forming station, where the parts are formed and cooled. After forming, the parts are trimmed, usually at a separate trim station where they are cut out of the plastic sheet. The part of the plastic sheet that was not used, called the web or the skeletal web, is recycled. The movement of the sheet through this machine is intermittent. The sheet must move or index, then stop so the heated sheet can be formed in the mold. The length of each index is determined by the length of the mold. Here is a thermoforming production line. Plastic sheet is fed to the thermoformer from a roll. The plastic is heated in one or more ovens and then moved to the form station. Depending on the product being made, vacuum, air pressure, mechanical force, or a combination of the three is used to shape the plastic into the mold. The plastic is cooled by the mold. The parts are removed, and then the excess plastic, the web, is wound on a spool to be reground and either blended with raw material for making new sheet or sold as scrap.
So that was the process of thermoforming. So now we know, if you never knew about thermoforming, or how this box that you buy all your takeaways in is made and how this process works. So this is how it is. So what I wanted to why I wanted to show you this, because you really needed to know. I want to stop it, and there was a view of the whole thing, kind of here, for example. So I wanted to show you this because I wanted you to understand how an automated system works. So for this machine, for example, it works using industrial automation, and it uses that PLC, that controller that controls that process. Start to think about your inputs and outputs. So for this process, for example, you have these plates, the heating plates for the plastic sheet. So these heating plates must have certain temperature. How do we know this? So input-wise, you will have a temperature sensor that measures the plate's temperature, and you will have the heating element turned on and controlled that heats the plates. You have the conveyor belt that moves the sheet across, and you have to move this conveyor belt, which is a motor, with certain speed, for example, and you have to stop in between. So when should I stop? How long? So this is timing, and this can be used. You can use timers or you can use actual sensors. When the plastic sheet reaches certain point, I will need to stop, or after I reach or pass certain distance, I will need to stop for 2 seconds for whatsoever. And then you can start to see the clamping and the molds sections and the cutting sections. So this is a force that goes up and down in order to shape it. So this is an output, and it is driven by, for this case, it can be a pneumatic or a hydraulic system. And either both, we're going to have a look at how does it work, but this is an output. So this is an example of how can you have an output in a force or in a form of a hydraulic or a pneumatic system. The closure or the opening of these plates. Or you can use a motor as well. It depends. Every company and every manufacturer of these systems, they build it however they want. So you can see now many different systems are interacting together, and many different things have to be coordinated very well. And this is what you do, and this is what you learn when you become an industrial automation engineer. So the whole idea is, how can I write the logic for all of this movement and interact every part of my process together? So start to look at how wiring and how the PLC kind of work. So what we have typically we get a PLC in this shape. So this is an Allen Bradley PLC Micro 850. So a PLC is this device, and it has that microcontroller inside. And within that device, you get two terminals. So you get an upper terminal and a lower terminal. And these are the terminals that are designated to connect and wire PLCs to them, to wire inputs and outputs to the PLC straight away. So from the top side of things, this might be or can be, it depends on the PLC, what's in the top and what's at the bottom. But for our case here, the top part or the top row of terminals are designated for all the inputs. An input can be a button, an input can be a sensor, an input can be anything that gives the PLC some sort of information or external information about what is happening. And for the lower part, this is going to be the output, where you connect the motors, the lights, contactors, relays, everything to it. So much easier actually as well to wire and to program as well, in comparison to the normal microcontroller, which is a totally different story. We will not get into it at the minute. So that's the way that the PLC work. You wire your inputs and outputs. You can see here, because it's a modern PLC, it can connect to the Ethernet at the top left part, and you have all the lights that indicates which inputs and which outputs are turning on or off. So as we just said, you can have any different type of input or output, and very highly utilized within an industrial automation. What you get used as outputs, you use pneumatics. And the pneumatics in general is using the air as an external power source to drive cylinders. These cylinders can be linear cylinders, like how we can see here. All of these are different length, size, linear cylinders, so it goes only in one axis. You can have rotational cylinder or rotary cylinders. So different shapes and different types, all depends on the applications. But for example, when we talk about linear cylinders, what you get various different characteristics. So diameter-wise, it ranges between 2.5 and 320 mil. Stroke lengths, so the extension and the retraction, so from 1 to 2,000 mils. And available forces from 2 to 45,000 Newton at 6 bars. And different speeds as well, from 0.1 to 1.5 meter per second. And in the design phase, when you are building a system, This is the symbol that is typically used for a pneumatic cylinder, that gray one at the top of the biggest cylinder on the right here. So this kind of the symbol for a pneumatic cylinder when you are designing a system. So how does it work? What you have a PLC, and that PLC, let's go back to this, our thermoforming machine, and let's focus on that mold section. So it opens and shuts over the plastic sheet to shape it. So in order to close it, it is, let's say, for this example, it might be using pneumatic system. So how can I use air to push down or up? So the whole idea is, well, you have a compressor, an air compressor, and that air compressor is just pumping air. What you want to do, you want to direct this air into that cylinder to extend so it can open the two plates of this of the mold. So to extend the cylinder, well, you need to pass, or you need to direct the air in order to apply the force for extension. And this happens using something called directional control valve. So the directional control valve, or the DCVs, are devices that are used to control the flow of the air between the lines. So, for example, you have different types and sizes and shapes of it, but we are using or focusing, having a very basic example of something called 3x2 way valve. 3x2 way valve means that, well, it is a valve that has 3 ports and it has 2 ways of operation. So when we look at this, what we have here, we have the valve inside. What we have an inlet port. So this is an input, and this is an exit port. And what you have here, you have the exhaust. So what happens is, this is connected to the compressor. So the compressor is just pumping air all the time. And what you have inside, you have that arm that controls where that air should go from and to where. So initially, what you see here, for this cylinder, it is 3x2 way valve, and it is a spring return valve. Means that, well, it has to have 2 directions. So these 2 directions, whether it is from whether to go to the left or to go to the right, it has to be done through by using some sort of power. So for our example here, this is using man force or human force to press it into one direction, and it is using a spring to push it back to that normal position once your finger is off the control valve. So in our case here, initially you have the inlet, and that inlet is always connected to the compressor. So you have continuous flow or pressure of air in here, and normally without pressing anything, you have the spring pushing the arm to the left direction, and you will see that this plate in here. So let's maybe change color if I can. Let's see. So this plate in here is blocking the flow of air. This is normal, so nothing is extending or whatsoever. So the air is blocked, everything is blocked, and the exhaust is open, meaning that, well, if you have any air inside the cylinder, it will be drafted out, and you start to have the process of operation or turning on this valve in a different direction. So first one, so here you have the inlet and outlet. Let's see. So you have all the inputs, and then you have your first press. So you're pressing from the left-hand side. So you're moving that spool to the right-hand side. And you can start to see with the movement, once it is moved, you will see that the exhaust is blocked from here. So there is no air that can escape. And the inlet or the exit to the cylinder is open, and just at this moment the exhaust is closed, and the inlet is closed. So start to move, and you start to see that, well, the inlet is opening, and the flow of air started to go from the bottom to the top. Yeah, you can see here. And this is your operating position or on position. So while you're pressing, while you're keeping your finger on the button, what you get a flow of air from point A, or the inlet, towards the cylinder itself, so it can extend and do whatever it needs to do. So once you remove your finger, what you will get the retraction. So once the spring starts to press from the left-hand side, because your finger is not there anymore, so it will return into the normal position, it will block the input, and it will start to open the exhaust. And you will see that this is how it works. So it's quite interesting to know how it works, because this is one of the most common used technologies within the industry in order to operate a fully automated machineries, especially with pneumatics, because it is clean, it is affordable, it's just air, and it's not that complicated or messy to establish. So for this valve, this is a 3x2 valve. You can have 5x2, so 5 different ports over 2, or 5x3, so 3 different positions. And this is the symbol for it when you start to design a system. You will start to see that on the left-hand side, this means this is an operating position, and the right-hand side, or the box on the right, this is another operating position. So it shows you what would be connected to what, really, when you have the symbol. So for our example here, this was totally man-powered from one side with your finger, and then a spring return. Well, you can have these two options in a different way. So you can have 2 buttons, manual buttons from both sides, or you can have an electrically or an electro-pneumatic type of it. And the electro-pneumatic type means that there will be, let's call it a device that will receive the signal here instead of this button. And when this device receives that signal, it will push that arm or that spool to the other position. And you will have another one on this right-hand side. When it gets the signal from the PLC to close, it will push to the other side. So you can have fully manual, fully automated directional control valves with different sizes and different types and operation ways. So that was kind of an introduction for you, and it is kind of a way to tell you what is industrial automation if you don't know much about it. So when you start to think about it, it is a step up from just being a purely electrical or a mechanical engineer, because the idea of industrial automation that you know many different things. So you know about electrical systems and mechanical systems and the programming, for example, or for sure, actually, because this is kind of the idea of it. So you have all of these different capabilities and all of these different abilities in order to construct and build a specific system like this. So this will mark kind of the end of kind of the technicality of today's class and how, what are the different things that I wanted to tell you about. So to move on, you start to ask yourself, how do we do this at the ECT? So ECT is a fully online university, meaning that, well, we don't have to attend to classes. So how are you going to learn about these different technical applications? So in our model, what we do, we are using different pieces of technologies, and we are adapting technology very well. So we are using our VLE, with Virtual Learning Environment platform, and that platform where you find all your recorded lectures, and you have the links to your live tutorials where you attend with your lecturer to carry out different practical elements of these different classes and these different ideas and the technical information of this of that particular class. But the practical element of things, we have 2 different things really that we use. We have something called remote labs and virtual labs. So the virtual labs are our servers and our systems that we are we built and established at the ECT. And what we do, we are loading these different servers with all the different softwares, the simulation softwares that you might need in order to carry out different applications. All of our softwares are industry-aligned softwares, and industry-aligned softwares, and they are the ones that are getting used in industry. So we are using them very heavily. Within the remote labs, what we have, you can tell us about Industry 4. Yeah, sure, in a second, absolutely. So just to finish about this remote labs, these are actual physical labs that we have, and this is what we use in order to deliver actual technical information and details. So we have at our campus, we have the actual physical kits, and these kits are connected to the servers, and they have the cameras on top of them. And for you, you can access the system remotely, and you can load your programs and see how the system interacts and behaves based on how can it work. The courses, right. Yeah, we have our recorded lectures, we have all of our different technology that will help you to have the required knowledge for what you need to do. Assessment-wise, we are using mainly practical examples with our industrial partners and the companies that feeds into our system, and it feeds into giving us actual problems that the industry has. It has certain issues in whatever, or carrying out certain projects of automating certain processes. This is something that we use and utilize. So we are heavy on developing your soft skills. So soft skills will be how to communicate, how can you talk to others, how can you write reports, how can you present your work, and give you that space and ability to innovate. So we focus very much on this. Very little modules, we have exams as well, but this is something must happen, for example, like within the mathematics and stuff like that. So where can you work when you are in industrial automation? So you can really work at the entire manufacturing industry. Yes, we are registered with Ofsted, and we have the degree awarding power, and we are in collaboration with IAT, so our accreditation body, which you will graduate with that accreditation. So the IAT is the top UK accreditation body that can help you with this. So each requirements, or all the different requirements, are on the website. So if you can just look at our website, I think Barry can put the link here to the ECT. And yeah, he did actually. So if you can have a look at the website, you will see all the different entry requirements based on where you are based and where your degree is from. And everything is taken case by case and application by application. So, and every country and every place has its own requirements. So please refer back to the website to get all the different information that you might need. So going back to the career opportunity, so the entire manufacturing industry in general, so oil and gas, food industry, plastic industry, metallurgical industry, whatever you want industry-wise, you can find. Hospitality industry, so if you thought about the cinema, about the theater, about the movies, all of this has industrial automation. That's for the entertainment. For hospitality, so every mall or every shopping center you've been through, or every commercial building or big residential buildings, they have industrial automation. So all of these different things, everything that you will find around you, even the oil and gas, has industrial automation. So whatever you're passionate about, you will find automation has a part of it, and it can have or has big impact on it, whatever it is. So what can you do with the degrees, whether it is an undergrad or postgrad, will depend on your career choice. So PLC and HMI programmer, and HMI is the human machine interface, the screen of that you interact with the PLC from. So PLC and HMI programmer, very highly demanded jobs. control system design and integration. So you can build a system. So like how this machine that we just seen, you can design the system for it from scratch. You want to build your own model. So this is can be one of the way. The commissioning and testing of different systems. And yes, Joshua, yes, Dean or Joshua, it is accredited by the IET. So first cohort will graduate with IET accreditation. So there is a difference between the IET and the EIT. So IET is the accreditation body for electrical engineering. It's one of the top UK accreditation bodies. And the EIT is the Australian sister university in Australia. So just same letters, different combination. Me, myself, was getting confused a lot about it or with it at the start. So automation systems, maintenance engineers, again, so your career opportunities can be everywhere and it can be in many things. So it is all about your passion and what do you want to do and how do you want to do things. So that will be it for me. Should I give it back to you, Barry? Or I can just cover and let you know about the upcoming classes or upcoming webinars if you wanted to attend. So you will get a copy of this slide, of these slides anyway, and you will get these details. And you can just ask for your certificate of attendance through the QR code here, I believe. And this is now the time for your Q&As. So when you start to look at Industry 5, you start to see that, well, it is now getting the focus away from technicalities and away from how the machine works and away from all the different technologies that we've seen before and started to shift towards human aspects. So how can the machines work with humans and how can we start to have that focus on people? And that was the whole idea of where Industry 5 came from. So human-machine interaction is quite a difficult area because one of the main issues with humans is resistance to change, for example. So resistance to change, meaning that what you will get a person that doesn't want to use your machine or doesn't want to actually use, doesn't want to change the way that he or she been doing over the past 20, 30 years. Through many projects that I did work on industrial automation integration, you will always get the resistance from people. So people don't want to change, don't want to interact or learn something new because of the fear of change. If I started to learn something else, this is going to be problematic for me. And this is going to be, I might not perform as good as I'm doing now. So let's keep where it is or where we are. So you start to see this idea of how can we change this? So we started to move with Industry 5 to human-centric and sustainable and resilient systems that has the environment or people and man and machine can work together to develop something useful. Industry 6, we started to look at autonomous systems. So you see now all these different systems that works by themselves and cognitive systems. So it's a little bit of a shady, vague area, but this is actually the way that things are going towards at the minute with Industry 6 ideas. How can we build? And we started to see that already with all the different AI models. And there are different talks that, well, cognition is already there and we have cognitive systems and the robotics development is happening in a different or in parallel in general. So soon we will get there. So let's take them question by question. Certificate be recognized in Ghana. I think Barry can answer this. What are the entry requirements? So just please go on the website. Barry put the link here and you will get the idea. Do your master's programs offer a good background for a PhD? Definitely. It's very focused on technicalities and different aspects of modern industrial automation systems. So it depends on what you want to do your PhD at later on. So if this is where you want to start, where you want to specialize with your PhD, so definitely can support, and it will give you a good idea. Difference between microcontrollers and microprocessor. Can they be implemented in industrial automation? Give examples. So microcontroller, look at your microwave. Do you have a microwave at home? Mizilu, if I'm saying it right. If you have a microwave at home, if you have a washing machine at home, this is a microcontroller. It doesn't do much really. It is very basic control of a domestic device that you can use at home. It is working in a in a clean environment and human-friendly environment. So this means domestic. So if you have a washing machine, if you have a microwave, if you have a kitchen equipment, if you have any of these things, your Apple Watch, even though Apple Watch can be more sophisticated now, but let's keep it within the washing machines and all of these basic devices. So a microcontroller is a device that does not have lots of intelligence. And when we say intelligence, means capability. Think about the microcontroller as a university or a classroom. What you get in the classroom, you have different seats. So different seats, meaning that, well, depends on the number of seats, I can do or deliver the lecture or the tutorial to either a larger group of people or a smaller group of people. So if it is a small classroom and I have that classroom can take up to only 50 students and I have 200 students, so I have to repeat the class 4 times. So meaning that the 200 students are going to get the information in for the time that is going to take if I have a classroom that I can accommodate or has 200 seats at one go. So you can see that this is the different end capabilities. And the capabilities means that it can accommodate. Think about the seat as the capability, or every seat in general, it will be a switch. And I don't want to get into this transistors area, but think about each seat or every place can do something. So when you have more of it, so you can do a lot at the same time. And when you have less of it, you can do less at the same time. And microcontrollers, you can wire things to them straight away. So they have inputs and outputs that you can directly connect to them. Microprocessor, this is your laptop. So the computer that you are using, it has a microprocessor. And a microprocessor has many different seats inside. So all of these different i7, i9, different cores. How many cores does it have? Think of them as how many seats does it have, and each seat can do something by itself or a certain instruction. So this is the difference. And if you want to connect anything to it, you have your microprocessor within your laptop or computer, and it is built or set up on a motherboard. So that motherboard is what allows it to connect to different devices. So microprocessor by itself, it doesn't connect to anything. It is just the brain. So if you want to connect anything, like how you connect your camera, your cursor, your keyboards, whatever you want to connect, it is through that motherboard. So this is kind of basic differentiation between both of them. So why the laptop has microprocessor? Because it needs to control each pixel. For example, as a very initial one, we're not going to talk about computing and whatever, but it can control every single pixel of your screen. And controlling that pixel, meaning that, well, it has to have, each pixel has the 3 colors or whatever, so it has to present to you different images in a very quick way. How can it do this? You need a lot of operation power. So that is basically what it is. So I hope that was useful. So let's see. Thanks for letting the time to develop. My question is, what automation rules today are most realistic to secure remotely? PLC programming, SCADA development, system integration, or AI-driven automation? All of them, Elvis. All of this can be done remotely. You can work remotely for the development of systems, for the maintenance of systems, for the operation, and how things can be done. So, and that is the power of the IoT and the communication that came recently within these automation systems. Remotely, you can have all of these different jobs, as long as you're not going to be responsible of the wiring, which is, it's usually happens by using a wiring engineer. And that wiring engineer is a person that is only specialized in wiring. So control panel wiring engineer or person. But for you, everything can be done within the automation systems remotely, from diagnostics, from operations, from the maintenance, and writing the different systems. So as a biomed engineering technician, how this relate to my work offline. So you will see that all of your devices that you have in the biomed sector or the health sector, this is automation. How does any device that works, that blood transfusion fusion devices, the scanners, the heart rate monitor, all of these different devices are automation. It is a domestic automation, which means that it is using microcontrollers, which is different a little bit from industrial, but it is all related and it is all delivered the same concept, really. So every device that you would have at your sector, the biomed, is industrial automation. So like an Apple Watch, you probably will get a microprocessor because of the screen and the complexity and all of these different capabilities that you have. Microcontrollers are very limited in their processing power. They can do simple tasks, but they cannot really go that above and beyond. EIT has a Doctor of Engineering. Is this doctorate relevant for teaching? And yes, absolutely. It's fully recognized PhD. So, yeah. The short answer to your question, Moses, is yes. Please, which is the best to understand application motor or servo motor and their differences? A motor and a servo motor is a totally different devices. They are both motors, but servo motor is a device or a motor that you can control its direction and speed accurately or in a very high, precise way. Think about robotics, all the different robots, robotic arm, or a humanoid, or anything. Pick and place system within a factory. All of these devices are using usually servo motors because, well, I need to control the acceleration, the deceleration, the speed, the direction of that motor in a very high, precise way down to the microns. And to do this, this is what the servo motor works. And within industrial automation, you learn a lot about servo motors. But for the different motors or the normal motors, they don't have this capability. You don't have that, well, you can have acceleration and deceleration capabilities and direction capability when you connect it to something called variable frequency drive or VFD. And that VFD kind of help in controlling the speed and direction of the normal AC and DC motor. But that is not really going to be as much precise and much useful for industrial applications like how it is with the servo motors. And an example for this, you will see it in the lift that you have at home, or if you're living in a building and you have a lift. So the lift using an AC or a DC motor, but has the acceleration and the deceleration and the direction in order to go between different floors. It is not that very high precise, and it's not down to the micron and the precision that you get from the servo motors. So this is basically kind of the big difference. Okay, thanks. How has the AI technology influenced the automation process? The AI influences the automation process, and how can you, or what can you produce? How can you produce, and when can you produce it? Very basic example, and we are running out of time, but I will give you an insight into this very quickly as an example. So what you started to get with the COVID time, you started to get more focus on digital marketing and digital e-commerce. So e-commerce meaning that, well, I don't have a shop anymore, rather than I'm selling out from a website. when I do have this, what it means that, well, I don't have a shop. So when I get an order from the website, that order goes straight away to the warehouse. So how was it used to be done, and what is the new way? In the old way, when you have a shop, you have a warehouse, and that warehouse will deliver twice a week, for example, to the shop. So if you're a clothes shop, so twice a week, you get a big pallet of different clothes and you put them in the shop, and the shop starts to put them out for display and sell them. But now you don't have the shop. So everything is going straight away to the warehouse. So what can I do now? Instead of delivering once or twice a week to the shop, you are delivering 100 times a day, depends on your traffic and whatever, thousands of times a day if you are Amazon. So you started to deal with single orders. So dealing with certain orders, how can I do all of this? You started to see the fulfillment centers. So the fulfillment center is a fully automated warehouse, and that warehouse can be controlled by ERP system. So that's a good thing. So how would I know what can I store in this warehouse? How, if I'm making clothes, so I have winter clothes, I have summer clothes, I have different accessories and different things. So I have Christmas jumpers. When should I, what should I store in all of these places? This is when AI comes in place. AI will come around to show you how these different distributions work, can provide you with a forecast, can provide you with a control of that system. So think about it this way, that the AI can look at the data and it will forecast, well, I'm coming towards Christmas. Well, Christmas is next week. So a lot of people are going to order Christmas jumpers and Christmas stuff, clothes. So I should stock more of Christmas clothes within my warehouse, so I can use all the spaces in a very good way or in a much useful way. And then I will receive the orders, and I will be able to send these orders to the fulfillment station or to the automated station when I get the order, to retract it and to package it and to send it out. Majority of these processes are already happening with AI. It's all about how can things be more automated. And at the minute, you start to see that, well, robotics are taking over all the fulfillment centers, and people are just in the packaging side of things. But all the orders come through the systems, and all the different applications or all the different predictions happens or can happen through AI models. So lots of different things came around. Is ACT Bachelor of Electrical Engineering recognized worldwide? Yes, it is. Well, every UK degree is recognized worldwide. So we are a UK recognized degree, and we are accredited by the IAT, so we definitely recognized. Which is the best variable frequency drive in the market currently? Well, that's a good question. Short answer, I don't know. It depends on your application, and it depends on what you want to use it for. You can use it in production, or you can use it as a small lift. So again, it's not something that you can just say, oh, what's the best one? Well, what's the best car in your mind? Well, you will ask me, what do you want to use it for? Well, you can use it for fun. You can use it to go safaris for the desert. You need a 4x4. You have rough terrain. You want to drive very quick. You want a very luxurious. Depends on your application. You have a best one. So when do you plan to have a PhD program in industrial automation? Well, we are planning for it within the next 2 years. So hopefully by then we will have everything established how we want. How I assume physics, electronics graduate can also study automation in MSc program, and how can we get certification in automation? Well, we need to know first what's the physics electronics degree that you studied included, and if you are working, what do you do at the minute, and how could it relate to the program? We don't want you to come and to get overwhelmed. We need you to come and continue your journey. So if this is something that you want to do, get in touch with the admission team, and they will help you to find out all of these details. Why is the on-campus doctoral engineering fee so high as 70,000? I assume you've been looking I don't know where you got these prices from. Is it from the Australian, the EIT, or I'm not sure. You mind? So just give me a little bit more details on these details.
Yeah,
I'm not sure.
maybe I can just step in. So, yeah, that's when you're studying on campus with us. So, yeah, so it differs because remember when you are on campus, you sort of like using hands-on components. So everything that you do, it's hands-on. So that's why the prices differs. Whereas when you are studying online, you're studying from your home country, and you're not using any of our facilities like hands-on components. So that's why you see the difference in terms of the pricing. Thanks.
Okay, thank you, Barry. So just quick, I think last couple of things. What are the requirements for MSc in automation or instrumentation course? Bachelor degree typically would be ideal for if it is mechanical, electrical, mechatronics, manufacturing. So it depends on your background. As a high national diploma of electronic equivalent to BSc. So again, get back to the admission team. I don't think the higher national diploma will be eligible for masters. You might need to take a top-up degree or a top-up year with the undergraduate program first, and then move to the masters. It depends. The admission team will confirm if it is equivalent to a bachelor degree in the UK and can be dealt with as a level 6 or not. So please just get in touch with the admission team and they will let you know. Being a fluid power trainer, this webinar might be very much useful. Okay, thank you very much for this. Thank you. You're welcome. Introducing it will be a PhD. Got it from the link. Right, for the presentation, you're welcome. So thank you very much for coming in today and attending with me today. It was good to see all your messages. Maybe in the next sessions or webinars, we can have more of a open mic interaction. So thank you very much, everyone. I hope that was useful. Thank you for your questions. Please get in touch with me, myself. I will put actually my email here in the chat. If you needed to ask or if you had any questions, please get in touch with me. Send me an email if you have any questions about the course, the materials, the way that it works or whatsoever. Please get in touch. Always happy to help. If you have any question about the qualifications, accreditation, stuff like this, please get in contact with the admission team. And you have our dedicated team that is always there to help you. So again, we are always here to help. Thank you very much for coming. I will hand it over to you, Barry.
Thanks, Abdul. Thanks very much. And so I've just displayed the QR code, and then I've also sent the link. So if you can just one more time scan the QR code, or you can just follow the link in order to claim your certificate of attendance. And yeah, from all of us at ECT, we would like to say thank you very much for joining us today. And I'm not sure if maybe you've got a few last words, Abdul.
Thank you. Thank you, everyone.
All right. Cheers.
Bye.
Bye.